Hold on,
then,
Tom, I have a question. Tom, it says here, I cannot highlight. Let W be the event that the system will work. What does it mean the system will work?
it's just specifying that components in certain positions are working. So for example,
well, work means at least one is working, not all zeros. It doesn't really specify in the question.
Okay, yeah. So like,
I guess because not all of them fail at the same time. Okay. Yeah, you can keep going.
Yep.
Yeah.
For part C, we have let A be the event that components 4 and 5 both failed. And so you can think of it as 4 and 5 have the number 0. And then the first 3 digits are the x's. And then again, it's the binary numbers from 0 to 7. So we have 8 outcomes. Or you could use a permutation for 2 cubed equals 8. And that's the number of outcomes for part C. And then for part D, we write the outcomes in the event AW. So AW
is intersection of A and W.
Yeah. So for A, that was the answer from C. And for W, that was the outcomes in part B. So the intersection is, does it show my highlighted part?
Hold on. The intersection, I'm not sure which ones. You said 2 outcomes, 11100 or 11000.
This is the intersection where
but your W, but check your W. W only have 3 members. Your W only have 11000.
Yeah,
W
so these probabilities, these will not appear in the intersection because they have 1s in the 4th slot or the 5th slot. So we can eliminate those from the intersection. So only 11xxx in the answer for part B is in the intersection of xxx00.
Hold on 1 second. But 11000 is not in W though. Hold on. 1100.
So,
11100.
Yeah. So that was this part. 1 and 2 are both working. So that's 11xxx. That's where I got this part.
Okay, so.
And these ones, these two are not in the intersection because they have slot 4 and slot 5 as ones, but but A has zeros for those slots. So when we're looking at the intersection, we just we find the elements that are in both of these that satisfy both criteria, where we have zeros that can be in the 4th and 5th slot.
Right. So it's and in W. What's your final answer for D?
And so we get 2 outcomes where it could be either 11100 or 11000.
Well, I would say it can only be 11000 because 11100 is not in W. Right?
Oh,
you see 11100.
Well, I interpreted it as 111 would still be in W because the first 2 are ones.
Oh, hold on. So 11100 is in the, hold on one second. 1 and 2 both working. 3, I see. Okay, all right. Okay, anyone has any questions? Great, thank you, Tom. Yeah, make sure, so everybody, when someone presenting, make sure we are all following and to learn and to, basically this is like a review the material we have learned before. Great, who is next?
Can you see the screen?
Okay, let me make it bigger. Oh, can you make it a little bit bigger? It does, I'm not able to do anything with this. What's going on? Oh no, thanks. Okay.
This is question 11 from chapter 2.
Okay. Yeah.
Of 120 person applying for a job, 80 have work experience, 60 have qualifications, and 40 experienced applicants have no qualifications. An auditor randomly selects an applicant. What is the probability that this applicant is A, qualified and experienced? Since the question has and, it means multiplication, and the qualified applicants are 60 over 120 people total, and then the experienced are 80. So 60 over 20 times 80 over 20 is 1/3. And then for B, what is the probability that this applicant is neither qualified nor experienced? So since there are 60 qualified applicants, the complement of 60 is 60 because there's a total of 120. And then the complement of 80 experienced applicants is 40. So 40 have no experience. So 60 over 20 times 40 over 20 is 1/6.
All right, since we have learned how to use the notations, try to use the notations. That will save you a lot of writing.
Okay, I just wanted to write it out so I, like, in the process of saying, I know what I'm saying.
Oh, I see.
Yeah.
I see. Okay. All right, anyone has any questions? So this is, who is this?
Young.
Oh, Yong. Okay.
Yongshin. Yeah.
Yongshin. All right. Okay, thank you, Yongshin.
Thank you.
Hi, Professor.
Hello. Yeah.
I'm going next.
Okay. You disappeared. It was up.
Yes, Professor, it's visible to you?
Nope. It was. I think it's coming up. Yes.
Okay, Professor.
Yeah.
I'm going to present question number 49 of chapter 2. A group of
Okay.
6 men and 6 women is randomly divided into 2 groups of size 6 each. What is the probability that both groups will have the same number of men? First of all, we have to find how many numbers are divided into 6. Total number of ways to divide 12 people into 2 groups of 6 each. 12 factorial over 6 factorial multiply 6 factorial. When we expand this factorial, we will get 924 answer. Then we have to find the next question, which is saying that what is the probability that both groups will have the same number of men? We have 3 men and 3 women. This means 6 men are divided into 2 groups of 3 each, and similarly for the women. So number of ways will be 6 factorial over 3 factorial multiply 3 factorial multiply 6 factorial over 3 factorial multiply 3 factorial. When we will expand these factorial, we will get 400. Then after finding these number of ways, we will find probability. Probability is equal to 400 divided by 924. So when we will divide it, we will get 100 over 231.
Great. Can you go up a little bit?
Yes, Professor.
Yeah, I want to go over this question again. This is great. So with applications, we want to find a sample space and the event. Can you go even up? Go from the very beginning,
Yes,
so everyone
yes,
can understand this question. Thank you. So now let's see. So the question is a group of 6 men and 6 women, right? We want to randomly divide it into 2 groups of size 6. So each group have 6. So now the question is, what is the probability that both groups will have the same number of men?
Yes,
Well, it could be 1 man, right? Or has to be 3, right? That's why you were
yes,
saying that. So there's no
yes,
any other cases. Okay. So total number of ways. So sample space. Total we
yes,
have 12 people. So there are 12 permutation. Then
yes,
because we have 6 men and 6 women, so we divide by 6 factorial, 6 factorial. So that's our sample space. Then
yes,
we want to have 3 men in each group because the equal number. Because each group have 6. Has to be 3, 3. So that's why he's saying, okay, number of ways for women, 6 factorial divided by 3 factorial divided by 3 factorial. Then number of ways for men, 6 factorial divided by 3 factorial divided by 3 factorial. So that will be the event. Then the event divided by the number of ways of the events divided by number of ways, the sample space. That's the probability of this question. Great.
yes,
Thank
Professor.
you. Great. Okay, good job. If anyone has any questions, feel free to jump in. Because I never have done this homework, the homework from this textbook. So I'm basically going with you guys.
Good evening, Professor.
Evening, let's see.
I'm going to present the question A from chapter 2. So the question is, the union of events A and B make up the whole sample space omega if PA equal to 0.6 and PB equal to 0.8. Find the probability of A, the events of all the possibility that A share with B. So A share with B is also the intersection of A and B. So I draw a diagram. We need to find the possibility of the middle part. And we're using the equation of P A union B equal to PA plus PB minus PA intersection B. And in this question, the possibility of A union B is equal to the possibility of whole sample space, which is equal to 1. Then we just plug in all the numbers, and then we will get the possibility of A intersection B is equal to 0.4. And B, the events of those possibilities that are exclusively AS. So the exclusively AS is also means only A. So we need to find the possibility of the first part, which is PA minus PA intersection B. We need to minus the A intersection B, which is because the middle part is not only A but also contains B. So also just plug in all the numbers, we will get the possibility of AS is equal to 0.2. Then C, the events whose possibility are either those of AS or those of BS that does not share with A. So in this question, we need to find the possibility of part 1, which is the AS, and the third part is the BS that do not share with A. So the part 1 is what we find in the part B, which is equal to the 0.2, and the possibility of third part is similar to what we did on part B, which is equal to PB minus PA intersection B equal to 0.4. Then we just add those two together. We will get the final answer.
Great, great. So this, yes, the Venn diagram is great. Yeah.
Mhm.
Yeah, I have no questions. Anyone has any questions? Great, good job. Sure. Okay. Who's next one?
Can you see my screen?
Yeah, yeah.
Okay. This is question 13. A certain town with a population of 100,000 has 3 newspapers, 1, 2, and 3. The proportions of townspeople who read this paper are as follows: 1, 10%, 1 and 2, 8%, 1 and 2 and 3, 1%, 2, 30%, 1 and 3, 2%, 3, 5%, 2 and 3, 4%. So I first create a table, and all the variable in this table are disjoint with others. So like I got 1 and 2 only, because in here 1 and 2 is 8%, but this 8% is include this 1%. So 8 subtract 1, I got 7. So this implies 1 and 2 only. And similarly for all those, and I got all those data for this table. Once I got this table, I can start with part A. Find the number of people who read only one newspaper. So we're looking for people who only read one type of newspaper. So that'll be the sum of those 3. So that will be 1 plus 0 plus 19 equal to 20%. That's equivalent to 20,000 people. For part
Hold
B,
on, I have a question. So no one only reads the third one, the 0? The third one is 0.
the third one, yes.
How did you find it?
So because for the third one, that only has 5%. And those 3 also counts 5%. So 5 subtract 5 give you 0.
Oh, I see. Because that's only 5%. 5%. No, 5%. So what does this mean? 5%. Oh,
So
means not only read 3. Means it reads 3. It reads 3. It's
yeah.
not only reads 3. I got it. So we
this
have the
table
minus
is for
2
only.
and 3. Okay. So that's why you minus 2 and 3 and 1 and 2 and 3. Okay, got it.
And for part B, how many people read at least 2 newspapers? So we're only looking for, because it says at least, so we also count this. So we count sum of those. So there's 4 variables. So that would be 7, 1, 3, and 1. The sum would be 12%. That's equivalent to 12,000 people.
Hold on a second. Let me see. So you have 1 and 2, 1 and 3.
3, 2 and 3,
What is
and 1, 2, and 3.
This is, so the first line is 1 and 2, second line is 1 and 3. What's the third line? 2
The
and
third
1?
one is 2 and 3.
What's the above? What's 2, right, 2 and 3. Oh, you rewrite it. So 1 and 2, right? Oh, you
For the
rewrite it.
duplicated
Okay.
one, they have the same symbol.
Right, that's the same. Right, 2 and 3. I see. So 1 and 2, 1 and 3, 2 and 3. That's right. So that's why 7 plus 1 plus 3. Okay.
And we got 12,000. And for
Okay.
part C, if 1 and 3 are morning papers and 2 is an evening papers, how many people read at least one morning paper plus an evening paper? So we're looking for, because 2 represent evening, and we need to find 2 intersect 1 union 3. So that's equal to 2 intersect 1 union 2 intersect 3. So that would be 2 and 1, 2 and 3, and 1, 2 and 3. So we got 1 plus 3 plus 7 equal to 11,000. And for part D, how many people do not read any newspaper? So we just first find the sum of all those and then calculate its component. So that would be 100 subtract 20, and then A, that's sum of 7 and 1, and 3, and 1. Then we got 68,000. For part E, how many people read only one morning paper and one evening paper? So we're looking for 2 and 1, 2 and 1, and 2 and 3, 2 and 3. So that would be 3 plus 7. That's equal to 10,000 people.
Okay. Yes, we can. Some of you, if we like pictures, we can also use the Venn diagram to achieve this. But I have one objection. 7 plus 3 equals 10% equals to 10,000. How those equals make sense? I know what you mean.
That's
Don't write
7% plus 2%.
Okay. Yeah. But don't write it equal to. All right. I understand what you mean, but make sure you write in another line. You don't equal them. All right. You 10% you multiply by 100,000, you get 10,000. Do you see what I mean?
It is 100,000.
100,000, right? You multiply by you get it. So don't write the equal sign here. Doesn't make sense, right? 10% equals 7 plus 3 equals 10% equals 10,000. Do you understand my objection?
Yes.
Okay. All right. But otherwise, this is great. Anyone has any questions? Okay. Thank you, Jie.
Thank you.
Okay, so let me, oh, I cannot move those ones. So who's next one? We still have Yongxin, Yinping. We have Raw. Yongxin.
I presented.
Oh, you did already. All
Yeah.
right. Yeah. Okay. I read. Right.
I'm here.
Okay. You're going next. Okay.
Yes, give a second.
All right.
Window, entire screen. Okay.
So the rest of you want to present, please get yourself ready.
Okay, question number 23. Two numbers from 1 to 10 are selected randomly in succession. What is the probability that their product is less than or equal to 50? Okay, if we have two successive number from 1 to 10, the total number of variations is 10 multiplied by 10, because the first number could be from 1 to 10 and the second number can be from 1 to 10. So the total number is equal to 100.
We mean the sample space. Let's
sample
try to
space.
use let's
Yes.
try to use the statistic terms.
Yeah, sample space is 100. Okay. So the condition is multiplication. The multiplication should be less than or equal to 50. Let's see what numbers could be that can meet these conditions. So if the first number is equal to 1, then the second number can be from 1 to 10. If the first number is 2, then the second number also can be from 1 to 10, because the multiplication will be less than 50. Okay,
Up
for
to
the
5.
third, from if the first number is 3 or 4 and 5, yeah, up to 5, that's it. Yeah, you're right. Okay, if the first number is 6, then the second number can be from 1 to 8. For 7, it can be from 1 to 7. For first number 8, the second number can be from 1 to 6. Okay, for number 9, the second number can be from 1 to 5. And for number 10, the second number can be from 1 to 5. If we add them up all together, we'll get 81 possible choices that suffice this condition. Okay, and the probability of the event will be the 81 over 100.
Okay. Great. Two numbers. Is there any other way? So we have to count basically. Basically, you count it. I mean, which is great. What if the numbers goes bigger? I was thinking if there's any other way of doing this. You know what? This is great. Thank you. Anyone has any questions? This is great. All right, next one. Yin Ping. Yin Ping, are you talking?
Oh, sorry, I don't open the mic.
Oh, so sorry.
So my question is 41, and is if a die is rolled 4 times, what is the probability that 6 comes up at least once? At first, the probability that no 6 in a row is 5 over 6, and for 4 times is 5 over 6 to the 4th power. So the probability that 6 comes up at least once is 1 minus 5 over 6 to the 4th power is equal 0.5177, about 52%.
Right, this question looks like a simple question. So this is one of the, right, we use one of the, so 1 minus is complement, right? It's easier to find this way instead of find, okay, it comes up once, twice, 3 times, or 4 times. We could do that way too. We add, probability of come up once, twice, 3 times, 4 times. Well, the easy way, a better way is to do 1 minus is complement.
Yeah.
All right?
Yeah.
Yeah. Okay, nice. All right, again, I would like to encourage everybody, try to use the notations in the textbook. Okay, next one. Okay, so we still have Andreli, right? Andreli, Catherine, maybe I'm wrong. If you have presented, let me know. And how? Raw.
Professor.
Yeah, Raw. You
Okay.
ready?
Yeah.
Okay.
I uploaded a file. Do you know
Do you know how to share your file?
Oh, I got it. Can you
Okay.
see this?
Not yet. First, you need to open your file on your desktop. It's coming up. Yes.
I'm on a tablet. Sorry.
Okay.
I don't know if I can scroll. Okay. I'm doing question 12. Trinica Tours offers 3 add-ons to people's holiday packages: meals, M, sightseeing, S, theater visits, T. And in the past, there's 31% that chose only M, 18 only S, 7 only T, 9 chose all. And then there's 11 that chose only M, only S, or only M and S. 8% only chose S and T. 7% chose M and T only. So first question is, what is the chance a client chooses exactly 2? Since these are all independent of each other, you can just add the probabilities of the ones where they only choose 2. So probability of M and S plus probability of S and T plus probability of M and T. And that's 11 plus 8 plus 7, which is 26%. For the second one, I tried doing this 2 ways, Professor, but the textbook says I got a wrong answer, but both ways I tried, I got the right answer, so I'll try to explain it. The question was, the client chooses one, or its probability the client chooses one or more options, excluding theater. So the first way I tried to do it was add every possible option where they choose 1 or 2 or 3 where there's no theater. So if they only choose 1, that means there's only probability of M, probability of S. If they only choose 2, there's probability of only M and S, because the other ones have theater in it. And you can't choose all 3 because that is theater in it. So I added 31 plus 18 plus 11, and I got 60%. But I don't know if I did it wrong, but that's not what the book had for me. You know what I mean?
Okay, so
And the other way I tried it was doing it backwards. So starting from the beginning and subtracting every option that the question doesn't want. So out of 1, I subtracted possibility that only T. And then for the ones where we only choose 2, I subtracted S and T and M and T probabilities, because those both have T in it. Then for all 3, I subtracted the possibility, because that has theater in it. And since it wants at least 1, I also subtracted probability of having none, because that's 0, and it wants 1 or more. And I got 60 for that too, so I'm not sure if I did something wrong.
okay, so we'll check on that. So first, you don't really need to write and, but you could write a notation like an intersection, or just leave like a PMS. So we understand that even the M intersect with even S. So no need to write and in between M and S. Well, let's check that. So P of M, of course, not including theater. P of S, not including theater. P of M and S, of course, not including theater. But is it any other ones not including theater? What about M and S and S? Oh, that's it, right?
Yeah. The only one it doesn't list is having none, which is actually part C. So what I did for that is subtracted everything it gave, which is 9%. So there's 9, and that was right. So there's 9% that chose none of them. But that can't be included in B because they want at least 1 or more in the question. And 0 is like, it's less than 1, so you can't add that.
Okay, that means probably you did it right, because the textbooks sometimes have typos.
Yeah, it's just the one I presented yesterday, you said I did that one or two, but the textbook said I had the wrong answer, so I'm just like, I'm not even sure anymore if it's me or not.
I'm going to check on this because I haven't never done this before. So 12, this is a 12. Anyone did a 12? It could be they approach it differently. But the question is very simple. The question is just asking, not including theater, right? clients choose one or more options, excluding theater. Right, just no theater. I don't see anything. I don't think
The
anything
textbook
wrong.
had 51%, so maybe they like subtracted a 9. Because there's 2 places to get 9%. There's all and none. So maybe they subtracted a 9 again for some reason. I don't know. The textbook said 51%. So but I don't see like why you would. I just don't understand why you would subtract all if you're not including it in the first calculation.
Well, let's see the question itself. The question says, so you have 31% only M, right? 18% only S. Oh, okay, Yinping also got 60%. Okay, let's not check anymore. Right? So just believe you did it right. All right.
Yeah.
Okay, someone left. Right, let's see. Oh, Reuven is in that left. All right, who's next? Let's hurry up a little bit. I'm planning to do some more examples today.
Hi, Professor. Can I go next?
Yeah, sure. Like here.
Can you see the screen?
Not yet.
Oh, sorry, it's not this one.
Oh, yes.
Sorry.
Oh, it's gone.
Sorry. Let me
Popped
share
up.
it again.
It popped up, then disappeared.
Okay.
The rest of you haven't presented yet. Make sure you try to present. That's part of your grades, and will also help you when exam comes. And everybody also make sure you try to finish homework 1, homework from chapter 1.
Can you see it now?
Yes. Now
Okay.
it's up again.
So question 9. In a school, 3/4 of students are involved in sports, half are involved in cultural activities, and 1/8 are involved in neither. Calculate the probability that a student is involved in either sports or in cultural activities. B is both sports and cultural activities, and C is cultural activities but no sports. So we have given probability A, which is sports, is 3/4, and probability B, which is cultural activities, 1.5. And then we have given probability that they are involved in neither, which is the probability. I use the notation over here, A complement intersection B complement, which is 1/8, which are given. And then so number A asks that probability of either sports or in cultural activities, which is probability A union B. So we have the proposition 1 minus probability A complement intersection B complement, which is 1 minus 1/8. And the answer is 7/8. And B asks both sports and cultural activities, so which is probability A intersection B. So we can get that from this proposition because we already have A union B. You can use that proposition to get A intersection B. Yeah. And C is probability that cultural activities but no sports. So which is A complement intersection B. So not sports but cultural activities, which is this proposition probability B minus probability of A intersection B. We have intersection B over here from number B, and we just make the difference of that, and the answer is 1/8.
Nice. Like you use the notations.
Thank you.
Yeah. You're welcome. Yeah, this is simple and direct. Okay, Catherine is not presenting today. That's okay. That's fine. You don't have to present every class. That's too tiring. Anyone else like to present? Andreli? Do you prepare to?
I
How?
will go.
Okay, how is up? Okay.
I will do question 17 from chapter 2. 25 people consisting of 15 women and 10 men are lined up in a random order. Find the probability that 9th woman to appear is in position 17. That find the probability there are 8 women in position 1 through 16 and a woman in position 17. First, I start to find the probability of 1 to 16. There says that 8 women is found, so there will be 8 men from the 16 of them. So I find the ways you can choose a woman. It's 15 choose 8, and then the men 10 choosing 8, and then the 25 choose 16 for choosing 16 people from 25. So what I got here is got 0.142 as a probability of choosing 16 8 women and 8 men from the above, and then there's only left with 7 women and 2 men. Then for choosing another woman from the rest it's 7 choose 9. Oh, 7
7
divided.
choose
7
7.
divided. And then what I did for the rest to get the result of this one is to multiply this one and this one to get the result of like getting the probability.
Okay, I have. Yeah. Let me understand the question. I don't think I totally understand the question itself. So 25 people. Okay, 15 and 10. 15 women and 10 men. So find the probability that the 9th woman. Oh, okay. The 9th woman to appear is in position 17. What does this mean?
Just the previous 8.
Okay, so we lined up these 25 people.
Yeah.
We have 15 women, we have 10 men. Now, find the probability that the 9th woman, so the 9th woman now appear in position 17. Okay, now I think I'm getting it. That is, find the probability that there are 8 women in position 1 through 16. Yeah, because the 9th one will appear in 17.
Yeah.
And a woman in position 17. All right, so you are saying, okay, let me think. Find the probability that are 8 women in position 1 through 16. 8 women. So you're thinking, okay, from 1 to 16, how many positions?
There's 8 women and 8 men, since it says that 8 women in the 1 to 6 positions.
Yeah, from 1 to 16 position, that's 16, right? 16 minus 1 plus 1, that's 16. Why you use 15?
Oh, because there's 15 women.
Out of 15 women,
yeah.
8 of them. I got it. So the previous 8 women, out of the 15, you choose 8. That's you get that number.
And
oh, okay. selecting A women from 15. Great. Selecting A men. Selecting A men
Amen
from
from 10 of them.
Why we selecting 10 A men from 10?
Because there's 16 of them, and it says that 8 of them it's woman ready.
Got it. So because we have 16 positions,
Yeah.
so we have A women and A men. So there's this many ways of doing that. Then totally selecting 16 people from this 25, there's this many. So the sample space would be, right? So this would be a sample space out of 25 to 16. Then the event is many ways of choosing women multiplied by many ways of choosing men. Then we get the 0.142. So the answer is not 0.142. Why do we have to keep going?
Because this is for 16 already, and we want to find the woman in position 17.
One woman in the position 17, right? Okay, got it. So there's, let me see.
So
there's
remaining
7 women left and 2 men remaining. So the probability of the next position is a woman is 7 out of 9. Ah.
So you times it to get the result.
So 0. Right now, great. So it's about 1%. Great, nice. Anyone has any questions? Nice, thank you, Hao. A question like this to present is great. All right, Hao. Anyone else?
I'm doing number 42.
Okay. I feel great because I'm learning from you guys. You guys are teaching me. Nice, good job, guys. Keep it up.
I'm doing number 42.
Okay.
It says 2 dice are thrown n times in succession. Compute the probability that double 6 appears at least once. How large need n be to make this probability at least 1/2?
Wow. Okay, good question.
Okay, so there is 6 possibilities in one dice throw.
Well, let's use the word outcomes.
6 outcomes. And since it's 2 dice, it would be the sample space would be 6 multiplied by 6, which is 36. So it's 36 outcomes from 2 dice. The probability of getting a double 6 is 1 up to 6 from the first dice throw and 1 up to 6 from the second dice throw. So when we multiply this, we get 1 over 36.
Hold on a second. Hold on a thought. Because think about this. Think about your list of 1, 2, 3, 4, up to 6.
Yeah.
1, 2, 3, 4, up to 6. Oh, yes. So others have 2 choices. For 6, 6. So I'm thinking the first one is 6.
First one.
Second one is the same. Yeah. It's the same. Yes. Okay.
Yes. All right.
Yeah.
So the probability of a double 6 is 1 over 36. For the second part, we need to minus the probability from 1 to get, if you want to see how large n needs to be.
Complement.
Yes.
Because I understand your point. Let's go up to the question to show everybody. Because this says appears at least once. We don't want to do appear at least once, right? We want to do 1 minus its complement. That would be, you know, we do the complement. Then 1 minus its complement will be the at least once. I think that's what you are doing. So 1 minus.
Yes.
You have that. Okay.
Yes. So the probability of not getting a double 6 is 1 minus 1 over 36, which is 35 over 36. And then 35 over 36 to the power of n, when we're trying to find n,
right,
to see what equals to half. So we use a log function.
So missing n. Where's your n? The 35 of 36 n. You're missing n here.
Right. To calculate the n, I had to divide ln 1 over 2 over ln 35 over 36, which is 24.6, approximately 25 times. So we have to roll 2 dice 25 times for it to be
To reach the probability
could be at least 1/2. Yes.
Great. Anyone has any questions? I like these kind of questions to be presented. Only one objection. This line you're missing n.
Oh.
If you scroll down, if you go down,
Here?
go down. Yeah, this one you're missing n. You could put an n up front, ln 35 over 36, or you can put an n above 36, 35 over 36.
Okay.
You have ln 35 over 36 equals ln half. That doesn't make sense. Okay, Ayat is saying something. Let's see his comments. N over 36. 1 over 36 for one row, n over 36 for n times. Yeah, what are you talking about?
Okay, in the question, it says that the two dice are thrown n times.
Right. To reach the probability of a half when the double 6 appears at least once.
Okay, for n times, it's going to be n over 36. For one row, for one time, it's only 1 over 36. For n times, n over 36.
You're probably thinking something else.
Like n?
Yeah, because I like Andrili's solution. It's a good solution. Because we have to consider, right? It's good. Okay. Anyway, anyone else like to present? Thank you, Andrili. Let me give you. Okay, I think so. Probably no one. I think almost everybody presented, right? Who claimed to present. Okay, let's quickly go over something I want to talk about today. Okay, my field of mathematics is topology and manifolds. So probability is not my strong suit. I'm here to learn with you guys. I feel great. Let's see anything. Okay, I see. Then n divided by 36.5 and equals 18, at least 18 rows. Yeah, you did not consider something else. There's another condition saying within these rows appears, so this 6,6 appears at least once. You have to consider that. Okay, anyway, I want to talk about a couple more examples. Let's see, 5i. I think 5i is a classic question. Okay, it's a classic problem. So 5i is saying if n people in a room, what is the probability that none two of them have the same birthday? So we assume a year. So to answer this question, we don't consider, February has 29 days. We just take every year has 365 days. So the question, then the second part is how large need n to be so that this probability is less than half? Well, let's just consider the first one. Right. So for none of them, for no two of them have the same birthdays, the probability would be this, right? The first one can have a birthday in any day. The second one would be, because it cannot have the same birthday, so only 364 days, so on and so forth, up to, because we consider n people, up to the nth, which is 365 minus n plus 1. That's how we count. That is how we count. We always use the big number, subtract the small number, then add 1 back to it. So that's the event. So these are people have different birthdays. For n people, have different, but the event, the outcomes, the possible outcomes for n people have different birthdays. What is the sample space? The sample space is 365 raised by NA. And if we do this calculation, and we find out n is at least 23. N is at least 23. And this probability, the probability is less than half. So very interesting, huh? As long as the room has 23 or 23 people, this is very interesting. I remember back then we used the number 25. Somehow this textbook uses 23. All the calculation, right? Anyone has any questions? This is like a classic question in probabilities. And you can finish reading the rest, talking about if there are more people in the room. 50 people in the room. The probability is surprisingly 97%. You know, none of two people have the same birthdays. Well, let's say example 5J. So we're back to the deck of 52 cards again. What's the setting? So the cards are turned up one at a time until the first ace appear. So that's a setting. Is the next card, that is the card following the first ace. So we flip the cards facing up, you know, once we reach the first ace. So what is the probability? Well, which one more likely to be? The ace of spades or the two of clubs? The two of clubs. So which one has a higher probability? The ace of spades or the two of clubs? Remember, the 52 deck of cards have 4 suits. Spade, club, the two of the suits. 2 is a number. Ace is, you know, one of the denomination. Let's see the solution. So to determine the probability that the card following the first ace is the ace of spades, we need to calculate how many of the 52 permutation possible ordering of the cards have the ace of spades immediately following the first ace. So how to begin this? Note each ordering of 52 cards can be obtained by first ordering the 51 cards, different from the ace of spades, and then inserting the ace of spades into the ordering. So then for each of these 51 factorial orderings of the other cards, there's only one place where the ace of spades can be placed. So it follows the first ace. For instance, if the ordering of the other 51 cards like such, so this is random, then the only insertion of the ace of spades into this ordering happens with, right? So this is ace of spades. it has to happen right after, immediately after the ace, right? So this is just ace of a club. This is just one random choosing. So it has to be in this ordering. Therefore, there are 51 factorial orderings that result in the ace of space following the first ace is this. So probability of the ace of space follows the first ace. Following the first ace is 51 factorial divided by 52 factorial, right? So this is a 51 factorial. And for ace space happens right after the ace appears, can only be such so, right? Which is simplified is 1 out of 52. Interesting, huh? So by the same argument, it follows the probability that the two of clubs, right? It's the same thing, right? Because think about two of the clubs, except the two of the clubs, not in the deck of 51 cards. The 51 cards also have the 51 permutation. And then the two of club has to happen right after the ace appears. So the probability should be the same. 51 factorial divided by 52 factorial is simplified to be 1 out of 52. So in other words, each of the 52 cards of the deck is equally likely to be the one that follows the first ace. This is interesting, right? Because by intuition, what's our intuition? You know, one ace already appeared. We only have 3 aces left in the 51 deck of cards. But okay, this is not only one. This is only one of the suits, right? So the clubs. So those two, but the intuition is, you know, maybe the two of club has more chance to, you know, the probability of the two of clubs appears is bigger than the ace of spade. No, like equally likely to appear. So this is also very classic probability, you know, situations. Let's see this one. This one I think has a lot of calculation. Yes. So let's go over this one. A football team consists of 20 offensive and 20 defensive players. The players are to be paired in groups of 2 for the purpose of determining roommates. If the pairing is done at random, what is the probability? What is the probability that there are no offensive defensive roommate pairs? So which means the offensive pair with offensive, defensive pair with defensive. What is the probability that there are 2 offensive defensive roommate pairs? Right? So 2 questions. The first one is no offensive defensive pairs. The second one is the probability that offensive and defensive pairs. Let's see this. So the total sample space would be 40 out of these 40 players, right? Pair them 2 by 2. Pair them 2 by 2. There will be 10 twos down here. And so what is it? So it would be 40 factorial divided by 2 factorial raised by 20. Well, we have to do this calculation, but I'm going to skip the calculation. We have to calculate it using the multinomial formula, theorem. So we have these many ways of dividing 40 players into 20 ordered pairs. Right, so the 20 of 2's here. 20 of 2's here. So it's 40 factorial divided by 2 raised by 20. So they are 40 factorial divided by 2 raised by 20 multiplied by 20 factorial ways of dividing the players into pairs of 2 each, right? So different pairs, right? This is how many ways of doing that. Then we have 20 pairs. So multiply by 20 factorial. We permute the 20 pairs. So the division will result in no offensive defensive pairs is the offensive and offensive players are paired among themselves. It follows that we have to divide by 10 factorial, 10 factorial. There are 20 factorial divided by 2 raised by 10 multiplied by 10 factorial for each. Right? For each, that's why raised by square. So 20 pairs divided by 2 raised by 10, then multiply by 10 factorial. Hence, the probability of no offensive defensive roommate pairs is the probability is this. So that's the sample space, right? We have 40 factorial divided by 2 raised by 20, then divided by 20 factorial. Then the event is 20 factorial divided by 2 raised by 10 divided by 10 factorial, multiply itself. Then to do this calculation, we have this. All right, that's a lot of information here. And anyone has any questions? Okay, let's see the second part of the answers. Then now, the probability that are offensive and defensive pairs. So out of 20, choose 2, right, to pair them up. So these 4i players can then be paired up into 2i factorial. Well, yes, we can permute. And it's so because the first offensive player can be paired with any of the 2i defensive players. The second offensive player with any of the remaining 2i minus 1 defensive players. Yes, that's why it's factorial. As the remaining of 20 minus 2i offensive players, or must be paired among themselves. So let's see this. Out of 20, choose 2i. Out of 20, choose 2i. Then permute this 2i of them. Then we have this, the rest of it is 20 minus 2i factorial divided by 2 minus 10 minus I divided by 10 minus I factorial. Then because of pairs, we square it. Okay, any comments? Oh, this is 2.5? Oh, okay, sorry, hold on 1 second. Yes, that's 2.5. Hold on. 2.5, question 5K. Question 5K. Okay, the I represents the roommate pairs, or number 1 pair, number 2 pair, so on up to number 10 pairs. Okay, then so the probability of 2i can now be computed, or they can be approximated by making use of result of Stirling. Okay, that n factor can be approximated. Anyway, this is for fun, okay? This is for fun. Don't mind this one, because we haven't talked about this one yet. Let's see example 5L. A total of 36 members of a club play tennis, 28 play squash, and 18 play badminton. Furthermore, 22 members play both tennis and squash, 12 play both tennis and badminton, 9 play both squash and badminton, and 4 plays all 3 sports. So again, you can do something like previously some people did already. You can use a Venn diagram, or you can use the notations. What's the question? The question is how many members of this club play at least one of the 3 sports? Whenever we see at least, we want to do is complement. At least one of these 3 sports, right? Which means they either play 1 or play 2 or play 3, the union of all those 3 situations. So we better find play no sports at all, right? Then do the sample space 1, probability of a sample space is always 1 minus, let me see if this one did no, this one actually says go directly. So probability, let's see this one. So let n denote the number of members of the club, and introduce probability by assuming that a member of the club is randomly selected if for any subset C of members of the club, we let the probability of C denote the probability that the selected member is contained in C. Then probability of C equals the number of members in C divided by the members in the club. Okay, so this is one way to think about it. Okay. Subset. What's a subset? Subset of playing at least one of the 3 sports. So now with the T being the set of members that plays tennis, S be the set plays squash, and B plays badminton. So we have probability of a T union S union B equals to probability of only play tennis, only probability only play only play in squash, probability only, no, not only, probability of members playing tennis, probability of members plays squash, probability of members play badminton, minus probability of members play both tennis and squash, right? Because if they play squash and also play tennis, it's counted in here already, counted twice. That's why we need to subtract once, then subtract the probability of members play tennis and also play badminton. So these 2 calculated in this one once, in this one twice. So subtract once. Same thing for this, for squash and badminton. Then, however, here we may have people play 3 sports, also here, right? So TS, TB, and SB. That means we need to add back the members play all 3 sports, which is a proposition of 4.4. So in this case, just plug in all those numbers given, right? Then divided by how many people in total? 36 members, right? 36 members. So divided by 36. Oh, hold on. What is this N? We can conclude that 43 members play at least one of the sports. Oh, okay. This N just a dummy variable. right? This n just a dummy variable. Do we really need this n? No, no, we don't need that. But because we want to show this is a probability, we don't really need to, we don't really need this dummy variable, all right? Okay, so that's one way to solve this problem. Well, there are different ways to solve this problem. But some of you already showed how to solve this kind of problem. Let's see this one. Ooh, this one is a lot of calculating as well. Let's see this one. The matching problem. Suppose that each of n men at a party throws his hat into the center of the room. The hats are first mixed up, and then each man randomly selects a hat. What is the probability that none of them selects his own hat? This is also a classic probability question. So we first calculate the probability of the complement of event. Right? At least one man select his own hat. So we denote the event by at least one, at least two, at least three, at least all n people, n people get their own hats. So we have E1, E2 is up to so. Now by inclusion, exclusion, identity, so probability of union of all those events, then in the end we're going to do one subtract this event. So this is the probability that at least one of the men selects his own head is given by probability of union of all those events, right? One man get his own head, 2, 3, up to n of them all get their own. Then use the formula, right? We add all this, similar to this. We add all the events, subtract intersections of any two of them. Then this is better. This is one of the propositions. But the calculation for us, let's see. Probability. So let's see. What is this one? Oh, okay. So the event that each of n men select his own head can occur in any of this n minus n factorial. Oh, I see. Yes, right? Yeah. So the first one has this many choice. Yeah. Then the second one keeps going. So that's n minus 1, n minus n factorial. Then we see the probability is n minus n factorial divided by n factorial. Yes. Also, there are out of n, choose n terms in this. So the probability of as all this is n factorial divided by n minus n factorial divided by n factorial, then multiply by n minus n factorial divided by n factorial. Simplify this to be 1 over n factorial. Yes, because this is out of n, choose a small n. Out of n numbers, choose this small n, the capital N. Out of this capital N, choose this small n. So simplify this, we get a 1 over n factorial. Hence, what do we get? If we do the calculation, we get a union, probability of union of all these events equals 1 minus half 1 over 2 factorial plus 1/3 factorial. That's going back to use this formula. So in the end, what do we get? This looks like one of the series. Yes, indeed, it is a series. So that's -1 raised by I divided by I factorial. I goes from 0 up to n. If we let x equals to -1 in the identity e to the x, the preceding probability then n is budget. Okay. All right, this is, let's see. All right, so the conclusion is when n is large enough, the probability close to e to the -1. In other words, for n large, the probability that none of the men selects his own head is approximately 0.37. All right, so yeah, if you are interested in this, because this is classic, some of them are classic probability problems. This is one of them. Let's see this one. 5, and compute the probability that if 10 married couples are seated at a round table, then no wife sits next to her husband. Okay. So this book is good. It collected all those like a classic probability questions. So we have 2 married couple, so sit around the round table, and no wife sits with her husband. So we let the event be this. So EI, I goes from 1 to 10, denotes the event that as couple sits next to each other. Right? We can find its complement, right? Like this one. So the first wife sits with her husband, 2 wives sits with her husband, so on and so forth. It follows that the desired probability is 1 minus probability of union of all those, right? 1 wife sits with her husband, 2 wives sits with their husband, so 3, so on and so forth. Then the 10 means every wife sits with her husband. So we want to find its complement with no wife sits with her husband. So this is much easier. So probability of union of all this, again, we use the formula. Okay. We use the formula, I think, in one of the propositions. So to compute, we first note that the 19 factorial ways of arranging 20 people around the table. Why? The number of arrangements that result in a specified set of n men sitting next to their wives can most easily be obtained by first thinking of each of the unmarried couples as being single entities. Oh, okay, that's nice, right? If they all sit with each other, so we can consider as just the couple as one entity. If this were the case, then we would need to arrange 20 minus n entities on the round table. And there are clearly 20 minus n minus 1 factorial. Yes, such arrangements. So finally, since each of the unmarried couples can be arranged next to each other in one of the 2 possible ways, it follows that, right, 2 raised by n, right, this couple sits with the next couple or different arrangements. So 2 raised by n times 20 minus n minus 1 factorial arrangements that result in a specified set of n men, each sitting next to their wives. So therefore, we have 2 raised by n, 19 minus n factorial. Right. 19 minus n factorial get from here. 20 minus n minus 1. And then divided by 19 factorial. Because there are 19 factorial ways of arranging 20 people around a round table. So again, from proposition 4.4, we have the probability. So out of 10 pairs, choose 1, 2 raised by 1, 18 factorial divided by 19 factorial. This is apply the proposition. Out of 10, choose 2. Out of 10, choose 3. Out of 10, choose 10. And the probability is about 34%. Oh, those are good. Those are classic probability problems. Anyone has any questions so far? Okay, last example for 2.5. Let's go over this one. Then we'll be done with 2.5. Consider the athletic team that had just finished its season with a final record of n wins and m losses. By examining the sequence of wins and losses, we are hoping to determine whether the team had stretches of game in which it were more likely to win than at other times. One way to gain some insight into this question is to count the number of runs of wins and then see how likely the result will be when all n plus m factorial divided by n factorial divided by m factorial orderings of n wins and m losses are assumed equally likely. So by a run of wins, we mean a consecutive sequence of wins. Right? A run of wins means consecutive wins. For instance, if n equals 10, m equals 6, and the sequence of outcomes was win, win, lose, lose, win, 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 lose, win, lose, 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 win, 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 win. Then there would be 4 runs of wins, because we have 1, 1, 1, 1, 1, 1, 2, 1, 3, 1, 1, 1, 1, 1. So we have 4 runs of wins. The first run being set 2, the second being 3, third one 1. So we have set 2, set 3, set 1, set 4. Suppose now that a team has n wins and m losses, assuming that all n plus m factorial divided by n factorial divided by m factorial orderings are equally likely. Let us determine the probability that there will be exactly r runs of wins. Right? R runs of wins. So here we have 4 runs of wins. So r runs of wins. How many r runs of wins? So this is 4 runs of wins. To do so, consider the first any vector of positive integers. So x1, x2 up to xr. Right? We have r runs of wins, and each one. So x1 plus xr equals to n, because we have n wins. Right? So x1 plus all those xr to be n. And let us see how many outcomes result in r runs of wins in which the ith run is of size xi. I equals to 1 up to r. For any such outcome, if we let y1 denote the number of losses before the first run of wins, y2, so y1 denotes the number of losses before the first run of wins. Well, let's see. So y1 would, in here would be 0. Right? This would be y2 LL, y3, y4. Okay. And the y r plus 1, the number of losses after the last round of wins. Right? So this is 0 in this case. All right. So then the yi satisfy this. y1 plus all those y r plus 1 equals to m, because we have m losses and wins. And each one of them can be 0. Let's see, y1 can be 0, yr plus 1 can be 0, but the middle ones cannot be 0, right? Because the middle ones cannot be 0. If the middle ones be 0, they won't count as 2 runs of wins. But the first one, y1 can be 0, yr plus 1 can be 0. But the middle ones separates the runs of wins, so cannot be 0. So y2, y3, up to yr cannot be 0. So let's see this one. So this is the one. So we have y1, x1, y2, x2, so on and so forth. xr and yr plus 1. So hence, the number of outcomes that result in r runs of wins, the S of the size, xi, I equals 1 up to r is equal to the number of integers y1 that satisfies the foregoing or equivalently to the number of positive integers. So y1 bar equals y1 plus 1. yi bar equals the yi if yi equals 2. Oh, okay. So this basically forces y1 to at least have a value, because y1 can be 0. And also yr plus 1 can be 0. So we want to force the y's to be non-zero. So we use y1 bar, yr plus 1 bar to represent. So in this case, we get this equals to, adds up all this, we get m plus 2. Now, all those y's cannot be 0, not zeros, right? All the wins cannot be 0. So the x, all the x's cannot be 0, because if it's 0, it won't be considered as one run of the wins. Now, what's up? So by proposition 6.1, there are m plus 1 choose r. Right, remember proposition 6.1 for non-zero solutions for this, or non-zero solutions for x1 plus, okay, x1 plus up to xr equals n. That means each axis cannot be 0. So non-zero solution is m plus 1 choose r. This is how many solutions, such outcomes. M plus 1 choose r. So the total number of outcomes that result in r runs of wins is this. M plus 1 choose r. And multiplied by the number of positive integral solutions. Right. Again, from proposition 6.1, this outcome result in r runs of wins. So out of m plus 1 choose r. That's how many such outcomes for this equation. Okay. Then we have r runs of wins. So how many r runs of wins? And out of n minus 1, choose r minus 1. Or multiply those two. Right, multiply those two. So 6.1, proposition of 6.1 give us this solution. Because there are n plus m out of n equally likely outcomes. Oh, this is how many wins in the whole situation, right? Because total we have n wins, m losses. So total we have n plus m. Out of this, choose n many wins. So that's a sample space. Then R runs of wins. So that's this many. So divided by the number of sample space. All right. So for example, if n is 8, m is 6, so we have 8 wins, 6 losses. Then the probability of 7 runs, n equals n wins, 7 runs. Can we have n runs? Okay. So for probability of 7 runs is this. What's the 7 runs? 7 is R, right? 7 is R. So it would be A7. M is 6. M plus 1. That's a 7. Out of 7, choose 7, but those two 7 are different. M is the number of losses. So this is for the outcomes of the losses, right? And this is for the outcomes of the wins. So multiply those two. That's the number of how many outcomes. So M is the number of losses. So this is example. So 6 plus 1, that's a 7. And we are considering 7 runs. So R equals to 7. So 7 out of 7. Then N minus 1. So total we have N wins. So N minus 1, 7. And choose R minus 1. We're considering 7 runs. So 7 minus 1, 6. Then divided by N plus M, 14. Out of this, choose how many wins? 8 wins. Right. So we do the calculation. That's this number. Let's see, this one's for 1 run. So only 1 run. So that means we have this, right? All the wins, the A of wins are together. So this is 1 run. That will be M plus 1, still 7. Choose R. R is 1. Then N minus 1, A minus 1, which is 7. Then R minus 1, R is 1. 1 minus 1 will be 0. So out of 7, choose 1. Out of 7, choose 0. Then how many in total? We still have 14. Choose 8. So that would be also 1 over 429. Right? To count 7 runs is the same as to count as 1 run. Okay, great. So anyone has any questions or any comments? Catherine, will you make future midterm questions based on the textbook examples and the homework questions based on what we choose? Of course, Catherine, you know me. I just choose questions from the textbook. Maybe some of questions you already tried and solved. Yes, no surprise. Is the midterm online or in person? Midterm will be online. Midterm will be online, and the final is in person. Final is in person. Okay. Any questions? You're welcome. Make sure you present. All right. Make sure you present, because when you present, I know where you are, and you know, basically we're learning together. All right. I'm having fun here. I'm learning from all of you, and I'm learning from these textbooks. It's great because when I learned the probabilities is yeah, I have done all those questions when I learn probabilities, but but it's not my area of study. All right, if you have no questions, go ahead, to do your homework and prepare to present next class. If you have questions, I'm happy to discuss with you here. Have a good night and have a good weekend. Thank you. Okay, I have 2 more new students. Catherine, is Catherine here? I think I have some new students here. Make sure you watch the recordings from before if you register late. I haven't seen Crystal. Where is Crystal? Let me send her email. Okay, I'm going to stop recording.